My name is Marcelo Precoppe, and in this short video I will be talking about a project entitled Upgrading Flatbed Dryers with Solar Power System. The project will start next month and will be funded by the GCRF Africa Food Innovation Award competition. We are very excited about this project. And as the title indicates, the project aims to improve flatbed dryers, like the one you see in the picture. It's a very popular kind of dryer, widely used by smallholders in developing countries because it's very versatile, simple, and rather low cost. However, this kind of dryer has two major issues. One is the non-uniform drying, and the other is the high fuel consumption. And together with Intermec Engineering, which is a local equipment manufacturer in Tanzania, we will be finding a simple solution to those issues. First, let's understand a little bit how the flatbed dryer works. It's a batch operate kind of dryer where the product is placed on a perforated screen and the product is dried by forced hot air. A fan, usually powered by electric motor, induces the air. The air is heated by a heat exchanger, and the heat is generated by a burner. The burner is usually fueled by diesel, kerosene, or gas. Let's first understand the root cause of this non-uniform issue. As mentioned, the product is placed on this perforated screen, and the hot air comes from the underneath, but the distribution is not uniform, and as a consequence, air velocity at the perforated screen is also not uniform. Neither is the temperature at the perforated screen. So as a consequence, the product does not dry uniformly. So that's the root cause of the non-uniform drying. Let's now turn to the high fuel consumption issue. And this is mostly related to the suboptimal contact between the hot air and the product. That means the air passes through the product, but the surface area between the product and the air is rather small because the product is agglomerated in lumps. If you compare, for example, with a pneumatic dryer, this surface area is much larger because the product is being transported by the hot air. So one of the objectives of this project is to develop a device that can be added to existing dryers and improve the uniformity, plus improve the contact between the hot air and the product. And to find out how this device should look like, we use discrete element method, DEM. And DEM, discrete element method, will allow us to make simulations and test different ideas, different configurations, different formats. So we do something like virtual prototyping. We will be working with a local equipment manufacturer also to make sure we can build something which is affordable and easy to install. And here we can see some preliminary study using DEM. For example, this device is very simple to build because it has only straight pipes, and then we can understand its performance. This device is a little bit different design, a bit more complex, and we can understand its performance. Maybe we will need something that also not only move the product but also breaks the product, break the lumps, and then we can test it also using the on different configurations and different designs. But the project is not only about developing this device. We will have another objective as well, which is to develop this very low cost solar collector to preheat the drying air. Auxiliary heating would still be needed to assure reaching the correct drying temperature and to allow drying under overcast condition, but will definitely reduce fuel consumption. And finally, the third objective of this project is to redesign the dryer's fan to operate with a DC motor coupled with photovoltaic panels. It will not use battery. We want aiming a low-cost system with no batteries and no inverter. We will operate only during the day, but also under partially overcast weather. Finally, we will build a prototype together with Intermec engineer in Tanzania and test it with Cassava on a Cassava processing center. So come again to visit us here because we will be presenting the results as soon as we have it. Thanks for watching.